Have you ever wondered how ships navigate the sea without sinking under the forces and pressures exerted by waves and wind? The stability of ships is their ability to maintain balance when floating in the water. This is crucial to prevent ships from capsizing or sinking due to the effects of waves, wind, or cargo. To achieve this stability, ships have various devices that counteract the swaying motion of the ship, called rolling. In this video we will show you how these devices work, and how they enable large ships, such as freighters weighing hundreds of thousands of tons, to sail through the roughest seas. One of these devices is the bilge keels, which are fixed fins placed on the side of the ship's hull, extending for almost 2/3 of the ship's length. These keels act like wings that generate an upward force when the ship tilts, helping it regain its vertical position. The effect of the rolling keels is greater the faster the ship travels, making them very useful for high-speed vessels. Another stability device is anti-rolling tanks, which are tanks installed across the width of the ship, containing water. These tanks serve to balance the ship's weight when it tilts to the left or right, causing water to flow from one side to the other. This reduces the rolling motion of the ship and improves the comfort of the crew and passengers. Anti-rolling tanks can be active or passive. Active tanks have a pump system that controls the water flow, adapting to sea conditions and the ship's load. Passive tanks do not have pumps but have openings allowing water to pass through due to gravity. How do ships maintain stability when subjected to the movement of waves and wind? In addition to the stability system we've already shown you, there are other devices that help reduce ship rolling or tilting. One of them is the active fin stabilizer, a fin-shaped device installed on both sides of the ship's hull, capable of moving in various directions controlled by the ship's sensitive steering system. When the ship rolls or tilts, the sensitive steering system sends a signal to the activation system in the form of electrohydraulics. However, active fins are not very effective when the ship travels at speeds below 10 knots or about 18 kilometers per h. In container ships, there is an anti-heeling system designed to keep the ship horizontal during loading and unloading in ports. The anti-heeling system cannot be used as a stabilization system at sea, and can only be used when the ship is in port, loading and unloading containers. Did you know that there is a system that prevents ships from leaning and capsizing at sea? This is called the anti-heeling system. The anti-heeling system allows ships to stay balanced when facing external forces that make them lean, such as wind, waves, or cargo. It consists of sensors that detect the ship's tilt angle, and ballast tanks that fill or empty with water as needed to compensate for the ship's weight. The anti-heeling system can be controlled by a main panel that regulates the operation of the anti-heeling pump, or by a start panel that allows the operator to manually activate or deactivate the system. The anti-heeling system is crucial to ensure the safety and comfort of ships, especially rescue ships that perform search and rescue operations. Rescue ships are vessels with the mission of rescuing people and property in danger at sea, whether due to accidents, shipwrecks, fires, or attacks. Rescue ships must be prepared to face the most adverse sea conditions, equipped with special tools such as radars, radios, boats, helicopters, stretchers, first aid kits, and fire extinguishers. Rescue ships must also consider the ship's balance points, which are the points determining the ship's stability. These points are the center of gravity, the center of buoyancy, and the metacenter. The center of gravity is where the weight of the ship is concentrated, the center of buoyancy is where the water's buoyant force is applied, and the metacenter is where the vertical lines passing through the center of gravity and the center of buoyancy intersect. When the ship tilts, the stability of the ship depends on the distance between the center of gravity and the metacenter, called metacentric height. The greater the metacentric height, the greater the stability of the ship. Therefore, rescue ships must calculate the ship's stability both at sea and in the port, to prevent the ship from capsizing or sinking. Can you imagine a ship completely overturning and then returning to its normal position? This is possible thanks to rescue ships with the concept of 180-degree vessels. These self-righting rescue ships are an innovative solution to face the challenge of extreme weather conditions and high sea waves that can hinder search and rescue operations, SR, and lead to ship sinking. Besides being able to self-right in extreme maritime conditions, several companies manufacture these self-righting ships. One of them is the Royal National Lifeboat Institution, RNLI, located in the United Kingdom. To create these self-righting ships, several essential elements are required to allow them to return to their original position on their own. How is it achieved that a rescue ship can return to its normal position after being completely overturned? The answer lies in several elements that make this engineering miracle possible. The first is the initial design of the ship, where all equipment and heavy objects must be placed as low as possible within the ship. The second is the crew's operation and control area, which must be light, resistant, and filled with air. Also, the access door for the crew must be watertight to prevent water from entering the space when the ship overturns. In self-righting ships, the operation is as follows. When the self-righting ship overturns, the weights of the pendulum system hang vertically, causing all open sections to close automatically and preventing water from entering the ship. These self-righting ships have an onboard system that detects if the ship is overturned. This system automatically protects the ship by turning off the radar and engines before straightening the ship to its original position. Once the ship returns to its normal position, the radar and engines are restarted. Additionally, crew members inside the ship must be seated and secured with seat belts to ensure their safety during an overturning event. These are some of the elements and technologies that make it possible for rescue ships to return to their original position after being completely overturned at sea. The ability to self-right is essential to ensure the crew's safety and increase the effectiveness of rescue operations in adverse conditions.